Okay, well, welcome everybody to ME564. All right, I'm Professor Mike Wagner. I'm an assistant professor in mechanical engineering. I started here about 2 years ago, and before I joined UW as a faculty, I was a researcher at the National Renewable Energy Lab. So I was there for almost 12 years and did work on solar energy, developing software, developing new technologies in solar. So a lot of my research interests are around solar energy and renewables, and then how you actually use renewables to meet grid demand and things like that. But a lot of what we do as well is like component design and heat transfer applications in solar. Okay, so hopefully we'll roll some of that into the class, and hopefully we can also roll some of what you guys are interested in into homeworks and things. So let me know as we go, and I can try to target those areas. All right, my office is 1343 ERB, the tall building. So what I'll do is we'll kind of go through just some background information for the first maybe 10 minutes. Kind of boring stuff, but probably worth at least saying so we're all on the same page. All right, so in terms of course coverage and how this class relates to classes that you might have taken before in heat transfer. So how many of you took 364 here? Okay, a few did not, that's fine. How many of you took a heat transfer course somewhere else? Okay, how many do not have an undergrad heat transfer course? One, okay. So it is possible to do just fine in the class without taking undergrad heat transfer. If you've had heat transfer somewhere else and you didn't, say, familiarize yourself with ease or some of the other things we'll be using, it is very possible. You probably just have to do the readings, put in a little bit of extra work up front just in the review part of the class, okay? Or if it's been a while since you took heat transfer and you've kind of forgotten some of it. So that brings us to the book. There is a book. It's Nellis and Klein. Let me just get it out. Oops. So it's this one here, blue cover, right? So not the intro one. I'll say strongly recommended. I'm not going to say go to table X and use it for an exam or anything, or I'm not going to assign problem sets from the back of the book or anything. But it's really useful, I would say, for the class. I follow along pretty closely with what the book does, right? So if you're confused about the way I say something, the book is a really good resource for you. This hard copy, I think, is too expensive, and there's a non-hard copy. There's a paperback version that's like $80, or you can get the e-version. Or I've heard crazy stories of people finding it online places. Okay, so which I didn't tell you. Okay, so in terms of the coverage, what we're going to do is there is overlap between this class and 364. We have to, we'll kind of cover, let's say, a third of what we cover you've probably heard before, but the 2/3 is hopefully new to you. So it's good to recap, what we learned in 364, but we'll definitely build on it and go in much more depth in this class. So those of you who are really recently took 364, you might find yourself in parts of the class thinking, I've seen this before, you probably have, but we'll kind of march through everything more quickly than we did before. In terms of what we're focusing on here, we really focus the class on solution techniques for heat transfer problems. Okay, ODEs, we covered in 364. We're going to get into PDEs. That's, ODEs in multiple dimensions. And we'll get into more depth in numerical solutions as well. Okay, in 364, we really focus on ease. We only really used ease, engineering equation solver. In this class, we're going to expand. We're going to use MATLAB to solve problems as well. Ease, we saw limitations for ease. MATLAB is a really useful complement to that. And then there's a tool called Maple. So how many of you have heard of Maple before? Less than half. Okay. Maple is, how many of you have heard of what's an analog, like Wolfram Alpha? Okay, it's basically like that. It's a symbolic solver. You can type in equations. You can take differential, do differential operators or integral operators or whatever, and it gives you symbolic answers back. Okay, it's almost like cheat code for engineers. Right? It's really useful. And we're going to get to the point where the ODEs and PDs we're solving, you'd be wasting your time if you do it by hand. Okay, so it's better to do it with something like this where you can just be confident in the answer. So what I want you to do as soon as possible is either download and install the software on your computer. You're going to want to use it. Or I think all three of these are available on XenApp through the remote.whisk or whatever it is. And you can use them that way. But make sure that you have access to them and you can use them probably by Friday, right? You don't have to be an expert in them right away. We'll learn as we go. All right. A few other things. These are kind of boring things, but just to give you a picture of how the class is going to work. Lectures, I call these traditional lectures, but I do want you guys to be engaged. I want you to ask questions and interrupt me. Hopefully I'll be able to answer your questions as we go. If we find ourselves sidetracked too much, I might say, let's have a discussion after class or whatever. The notes themselves, I'm going to post these skeleton notes, what you see here, the kind of semi-filled in notes. You may or may not use them. You might find them helpful. You might not. You don't have to use them, but they'll be available in the Files tab on Canvas. So that's here. So if you go to this Files tab, this is where you're going to find everything. So you would see here in the Lectures area for this lecture, we have the blank notes posted, right? And you can use those if you want. For other lectures, when we're actually going through other stuff, like if we use Maple, I'll have the examples posted here as well, and you could download those before if you wanted. Okay, and then I mentioned before, but the lectures are going to be recorded. This is basically a COVID accommodation policy, so I don't want people coming if they're sick. I want you to feel comfortable. Just I would say let me know before, and then I'll make sure that I accommodate if you're online, accommodate you. Everything's managed through Canvas. Submit your homework there. Grading. All right, so grading is, we have 3 exams. There are going to be 2 midterms and 1 final. They're all 20%, and they're all kind of covering the chunk of class that they correspond to. So the final is not really cumulative, other than the fact that it's building on prior material. Homework is 35%. It's the biggest part of your grade. Homework is I'd say the most time intensive part of the class. If you had 364, you probably kind of know what to expect there. But nominally this is 3 credits, right? 3 credits means about 10 hours a week. For a grad class, maybe that's a little bit more, but that's kind of the expectation. You're spending 3 hours here, right? So that means where's the rest of your time going? Well, it's going into homework, okay? The homeworks are not intentionally confusing or trying to find some hidden answer or something like that. They're just realistic problems, right? And realistic problems are challenging. I am toying with the idea of doing lecture quizzes just to check kind of how you guys are understanding what I'm saying as we go. I don't have anything right away today or anything like that, but I do reserve the right to give you sort of end of lecture kind of knowledge checks. Those would not be like graded strictly. It would just be, did you give a good effort and trying to understand what's happening? Okay, and then the second bullet point, the class is graded on a curve, all right? And so there's about 20% A, 40% A, B, and B each. This is a grad class, so we're not really expecting a lot of people to be below that level. And usually it's pretty clear, like if you really are struggling, there's a very few cases where it's below that. And then there's no intention to have a number of people fail or anything like that. But what I'll do is that before and after each exam, I'll just post on Canvas probably, here's where the curve cutoffs stand. Hopefully it corresponds to like a traditional grading scale pretty closely. Okay, office hours. What I'm planning to do for office hours are Wednesdays. Maybe today I'll stick around a little bit, but there's really not much to talk about. But what we'll do is, I don't think there's a lecture scheduled after this in here. So we'll just hang around in here for an hour afterwards, and we can do office hours here. If we get booted out, then we can move it online or find another room. And then tomorrow or Thursdays, I would have Zoom office hours, 12:30 to 1:30. And I'll try to do it in person and Zoom, just because I know you guys have different preferences when it comes to office hours. Okay, anything else? Okay, last quick slide. What do I expect out of this class, or what are the expectations for you and for me? Expectations, I talked about the time spent on homework. These should be a significant amount of your time. But you shouldn't find yourself like banging your head against the wall because you can't figure out what you're doing in ease or something like that. If you find that you're stuck, try to start early enough where you can come to office hours and ask, or send me a quick email, right? I don't want you to waste your time on stupid stuff. I want you to get heat transfer out of this heat transfer class, not debugging ease out of the heat transfer class. Right? In terms of attendance, I expect you to attend in person if you're able to. If you're not able to, then I would like you to attend live on Zoom. If there's an emergency that comes up, I'm not taking attendance, but I expect you all to be here and participate. Right? That's kind of the goal, and I think the value of being here in person. But yeah, just contact me and we can be flexible if needed. My email's there. I also have another email, mike.wagner@wis.edu. They both go to the same place. Don't email michael.wagner. That's a different person, and he's in journalism, and we are constantly getting each other's emails, and it's really annoying. So don't do that. I will try to respond within 24 hours. If you don't hear from me and it's urgent, you can send me a reminder. I won't be offended. Okay, and then there's a grader. The grader has very limited time on the class, like a few hours a week. So I really don't want you to be contacting the grader. In fact, I probably won't tell you who the grader is for now, just so they don't have to go through, if there's a problem with the homework grading, please come to me first. And hopefully there's not issues there. Okay, moving on. Okay, any questions on that, like background, boring stuff? Yeah. Yeah, at least, so there is from what I've done. You can go to the EASE website. There's a CAE EASE website, and there should be a download link and an academic license that you can get from that. And I think you have to log in using your UW credentials. Okay, so you can do that for EASE. You can actually do that for MATLAB and for Maple as well. I've done that because I use it enough. I find it annoying to go through XenApp all the time, and it's just nice and it runs faster and all that. So that might be something that you guys want to think about doing. Yeah. Anything else?